Today we're going to talk about kinematics. All right, I think this is a very difficult topic for maybe student, especially if you do not take physics or combined science physics. So unfortunately, this is a part of math syllabus, and you need to know well enough to actually use the speed time graph, sometimes convert to distance time. So pay attention if you need help in this. Okay, this is a kinematic relationship table that I come up with. I think for those students who are not taking physics, it'll be easier for you to understand the table, the graph. Speed time graph. In the speed time graph, the gradient represents the acceleration, and the area under the graph represents the distance traveled. All right, and the distant in the distant time graph, the gradient represents something else. So some students actually get very confused by all this. So if before you carry on, I would advise you maybe stop the video, copy down this table, and use it to refer to the question later on. Okay, and so I go on. Now, what does it mean by gradient? This is a speed time graph. Can you see what is my speed time graph? It means the y-axis is speed and the x-axis is time. In this case, the gradient, here you can see that the gradient is positive. And because the speed time graph, it represents the acceleration. That means the acceleration is positive here and is constant because the gradient is constant at a positive value. Over this stretch, you can see that the gradient is 0 because it's horizontal line. That means the acceleration is also 0. The last stretch, you can see that it's downward sloping. So the gradient here is negative, which means your acceleration is also negative here and is again constant. Okay, what does it mean by area under the graph? Okay, don't be confused. I mean, for this case, it's quite straightforward. It's just under the graph. Actually, it should be from the graph itself until the x-axis. Oh, please be clear about this. Okay, next we're going to do some questions. Let's try this question ourselves. Car A accelerates uniformly in a t second and continue at a constant rate. So you can see this line here. There's a straight line. This is for car A. Before decelerating to a rest. Oh no, it's not. This is first t second. No, it's this shape that looks like a trapezium that is car A. Car B is the one that is a straight line throughout. Okay, find the deceleration of car in the last 10 seconds. That means this last 10 seconds from t equal 9 to t equal 19. So first, if you want to find the deceleration, remember, if you go back, in a speed time graph, acceleration is the gradient. That means deceleration is also acceleration, but it's the negative of the acceleration. It's telling you the acceleration is negative, which is true, right? Because the gradient here is downward sloping. So what we need to do is to find the gradient of this car A graph. So how do we find the gradient? Let's see. Let's find 2 points. First thing, what is this point here? This will be 19,0. And this point here will be 9,9.5. This is what I advise you to do so that you do not make mistakes in exam. So gradient is equal to, remember, y2 minus y1 over x2 minus x1. So I'm going to take 0 minus 9.5 over 19 minus 9. And I'm going to get negative 9.5 on top. Below, I'm just going to get 10. Okay, and it'll just be negative 0.95. Now, this is the gradient, which is also the acceleration. Now, take note, the question actually asks for deceleration. That means the deceleration is the positive one. The deceleration is 0.95. And please remember to give them the unit. Take note the speed is meter square. So this will be meter per second square. Okay, quite a simple question. Next part. Car B. Find that car A and B complete the same total distance in 19 seconds. That means in 19 seconds, they complete the same distance. Find the value of t. Now, if you go back and see the table again, It shows you that the distance traveled is the area under the graph. That means the area under here, I'm going to use a red color ink, under this triangle. And can I change ink? I don't think I can change like that. Okay, never mind. Please bear with me. I'm going to shade in the other direction. Under this trapezium. Okay, it's the same. Can I erase? Can I erase? This is my erase button. Yes. Okay, so first, let us find the triangle. If car A, distance traveled by A. So distance traveled by A is effectively just 19 times 12 times half, which means area under the graph. Okay, this will tell me that it's actually 19 times 12 times half, which is 19 times 6. Where's my calculator? 19 times 6. 19 times 6 is 114. So this is 114 meter. Distance traveled by B is equal to, oh no, that's different, sorry. This is by B. Once again, I identify them wrongly. So please don't make this mistake in exam. This is A. Sorry, on top is B, this is A. A is the trapezium. Okay, so trapezium is, there's a portion where it's T, and then there's a portion where it's 19. So area of trapezium is half times the sum of the two parallel sides, which is in this case, the longer one is 19, plus the shorter side, which is actually 9 minus T. Right, because T is an unknown. Right, you take 9 minus away T, you get this part, which is here. This is the sum of the two parallel sides multiplied by the height. The height is 9.5. Okay, I have to do a bit of simplifying first before I actually calculate. So half times 19 plus 9 will give me 28 minus T, and the whole thing times 9.5. So maybe I should just take 9.5 times half first. No? Okay, 9.5 times 0.5 is 4.75. 4.75 times 28 minus T. 4.75 times 28 is 133. 133 minus 4.75 T. Okay. Now, since the since the total distance traveled is the same as given in the question, that means 114 is equal to 133 minus 4.75 T. Let's adjust a bit. 4.75 come over. 114 come over. 133 minus 114. It will give me 19. So T is 19 divided by 4.75. Will give me 4 seconds. And it makes sense. Okay, so my T is 4. Okay, we are here to draw this distance time graph. I think this is what most students will find the most difficult and most challenging of all these kind of kinematics questions. So let's just say first step. I'm just going to put it down in steps. So I'm going to write in this corner. First step, what you should do first is to calculate all the area in your speed time graph. All these, which I have calculated beforehand so that we can save time. Alright, so I'm just going to go right here, calculate the area. Now, if you can, please answer me. What does area under the graph represent in a speed time graph? If you forget, please refer back to the table. It represents the distance traveled. Okay. Calculate the area under the speed time graph. All the areas. All right. 2. Mark out the distance. The distance here is in the distance time graph, not in this. Okay, so I'm just going to do this number part 2 now. Okay, first thing, use a ruler, please. I don't have a ruler on this screen. This one will be distant because we are drawing a distant time graph. Unit is meter. And then draw a horizontal line. Where is my line? Okay. This should be time. Okay, and it should be in seconds. Okay, so first thing, 24. Mark out the time first. 5, 11, and 13.2. Now, it traveled 24 meters from 0 to 5 seconds. That means at 5 seconds, you have already traveled 24 meters. So now you have to mark 24. I'm going to mark it here. So it would have been here. Total distance traveled at 5 seconds. After 11 seconds, if we have traveled a total of 24 plus 57.6, because 57.6 is between 5 to 11. But your distance time graph is for the total. So when you add them together, you get 81.6. So 81.6 will be nearer here. Okay, again, mark out the coordinate first. At 13.2, if you add 18.4, you'll get 100. Okay, so that's the step 2. Mark out the distance and the coordinate. Of course, please follow. Then you can, you need practice. And then you know what to do next. After you have marked out the coordinate, then you draw in the gradient. I specifically use the word gradient. Why? Because gradient in a distant time graph, refresh yourself, it means the speed. Okay, and where can we find the speed? We can find the speed time graph. We can read it off the y-axis. So from 0 to 5, how is the speed changing? If it is changing, how is the speed changing? It's increasing from 0 to 5. That means the gradient at 0 here must be almost horizontal. And then it must come up to 9.6 here. That means it must be steepest. That means it must be increasing. Okay, make sure it looks like a curve. Then from 5 to 11, it is constant at 9.6. So your gradient here at distant time graph is a constant. That means it should be a straight line. Use a ruler, please. I don't have a ruler on the screen, so I can't use a ruler. But paper, please use a ruler, okay? And then make sure it meets the point. Of course, it's a sketch. It's not a real graph, so it doesn't matter. You just adjust your point back. Next, okay, at 13.2, you see from 11 to 13.2, what's happening? The speed is decreasing. From 9.6 is decreasing to a certain value that we don't know, but we know it's decreasing. But has it reached 0? No, it has not. So you must take care. But can I just look again? Is the gradient negative? No, right? It's positive. Is the speed negative? No, it is still positive speed. That means the gradient is still going upwards. Okay, gradient is still sloping upwards, but it's becoming lesser. That means it's becoming more gentle. Okay, so you must curve in this way. Okay, I know. Too many lines. Let me just erase. Curve a bit. Okay, so generally is curve, straight, and then curve. Okay, these are the two main points. So here is straight, here is curve upward, here is curve becoming more gentle. So it should look something like this. And generally, the shape are almost always like that. Okay, anything? Just going to erase this. Okay, try on your own. In fact, you can look for more question on other schools exam paper, and then you can try yourself. And if you have any question, please leave in the comment below.